All right, hello, Kaylee and Jack, and whoever else is watching this from the 8th period class. We are starting with number 16, and this is day 2 of the semester review paper. So 16, and I think we're going to try to get through maybe just like 31. So we'll try to get to all the way to the bottom. That's a lot of stuff. We'll see. We'll see how long it takes. We might stop early. We'll see. Okay? So 16, describe the end behavior. What? You can't see anything? You don't need to see anything. That's what you were yelling at. Okay, I thought you were talking something else. All right. Yeah, all right. Okay, they think they need to see something. Here, there we go. Okay, end behavior. End behavior. X goes to infinity. Y goes to blank. X goes to negative infinity. Y goes to blank. Okay. All right, X going to infinity means on the right side. What's he doing on the right? Going up. On the left, he's going down, negative infinity. Those ones are pretty easy. We know how to do those. Amen. Those are pretty good. Amen. Yep. Find the X and Y intercept. Ooh. I hope she didn't have any water in there. Oh, she might have. All right, X and Y intercepts. To find the X intercept, you do what?
Plot 2. No.
To find the x-intercept, you do something. Find the y-intercept, you do something.
Graph.
I mean, you can, but they want us to find the x and y-intercepts first. You plug 0 in for y.
Oh, yeah, that's what I meant. You mean x. Oh, I mean.
And you plug 0 in for x. So you plug 0 in for the opposite one. Okay? Now, you could just graph this linear function, and I know how to graph it, but practice doing it this way, because if I give you like a quadratic function, it would be easier to solve the intercepts first before you graph it, okay? So if I plug 0 in for y, I have 0 equals negative 1/3 x plus 2. Okay, that's 0 in for y, and I have to solve for x. So let's subtract the 2 over. So I have negative 2 equals negative 1/3 x. And then what? Then what do you do to solve for x?
Now we're going to divide.
How do you get the 1/3 moved to the other side?
Oh, we multiply.
Divide by negative 1/3 or multiply by negative 3 times negative 3. So the x-intercept is going to be?
Ow. What is this?
6. Yeah? X-intercept is 6. Okay? The y-intercept.
Wait, can you go back real quick?
Oh, yep.
Multiply by negative 3?
Yep.
Wait, I'm confused. What's going on?
Just wait and I'll catch you up here in a second. So just wait for us and we'll skip to number 18 for you real quick. Okay? For the y-intercept, we plug 0 in for x. Okay? And negative 1/3 times 0 is 0. You guys probably know this already, that it's just that last number. Okay? And then we can graph it using the y-intercept. So, or x and y-intercept. The y it's intersecting at 2, the x is intersecting at 6, and I just connect those dots. So that's what my linear function looks like. Okay? Which would be the same if we would graph it the normal way that we're used to. So we would start at 2, which is here, and go down 1/3, down 1/3, or up 1, left 3. I would get the same answer. So that's what that will look like. Good? But the x and y-intercepts are 6 and negative 2, or 6 and 2, I mean. Got it?
Yep.
Good? Okay, now we've got our transformations. Transformations. Do you want me to write down? Yeah, maybe I'll write them down. Okay. Your parent function is this guy. This is the parent. He's the one that we're starting with, okay? And then we have to decide what is happening to this one. So like, what is the 3 doing and what is the negative 4 doing? Okay, so we've got those 2 things that are happening. What is the negative 4 doing? How does that move it? Do you want to write the rules down first? Sure, let's write the rules down. Okay, rules over here. Let's say we have y equals x squared is my parent function, which is what it was up here. Okay, that's my parent function. And let's say I want to go to let's go up 3, and then let's go down 4, and then let's go left 2, and then let's go right 5. Okay, let's see what those look like. Okay, So how will this function change if I'm going up 3? What will that do to the function?
It will move it up on the y-axis.
Up on the y-axis 3, but what will the function look like?
Plus 3.
X squared plus 3, yep. Okay, what about down 4? X squared minus 4, okay? Now, what happens when we go to the left 2?
I don't know.
This one is where you have it inside of parentheses.
Oh, in parentheses, x squared.
No, it's just
Minus 2.
X and left is actually plus. This is where you use the opposite sign. Opposite sign. So left, which you would think would be minus, you actually do plus. So that's what that looks like. That's what left 2 looks like. So what would right 5 look
X
like?
minus 5 squared.
X minus 5 squared. So the square goes on the outside of the number. Do you see how that's different than up, down?
Yeah.
Okay. All right, so there's those. Okay, now let's talk about the next one, which is a vertical stretch by, let's say, 3, a vertical compression by 1/4. Let's do a horizontal stretch by 2, and a horizontal compression by 1/5. Okay, let's do what those come out to look like. So if I'm keeping my parent function as x squared, what does it look like when I vertically stretch by 3? If I take you and I vertically stretch you by 3, that's making you 3 times as tall, right?
X squared times 3.
X squared times 3 or 3x squared. I'm going to put the 3 in the front instead. Okay? If you're vertically compressed by 1/4, you're a fourth as tall, right? Or your height is a fourth of the times that it was before, right?
X squared minus 3?
So it's a 4th x squared. You see how that works?
No.
No? If we started with x squared and you're vertically compressing it by 1/4, you're just multiplying by 1/4. 1/4 times x squared. So 1/4 x
So
squared.
vertical compression and vertical stretch is the same thing?
I never
Yeah, it's the
understood.
same rule, but it's like, so you're just multiplying out in front, but a stretch will be a number bigger than 1 and a compression will be the number smaller than 1. So these two will look exactly the same. Same as this one though, right? Up and down, that was saying the same thing, it's just one's plus and one's minus. These two went together, one was just plus, one was minus. These two went together, one was just bigger than 1 and one was less than 1, right? Then these two should look the same, but a horizontal stretch by 2, this is what it looks like, okay? It's inside of the parentheses, but instead of using 2, you use 1/2. That's the rule for a horizontal stretch by 2. Okay?
So this is gonna be the same, just x
Mm-hmm.
squared.
And so this one,
Ow.
if we're doing a horizontal compression by 1/5, what number do you put in the inside?
5.
5. You flip it, right? So in this one, you use the reciprocal. You use the reciprocal, you flip that number.
Why was the sheriff here this morning?
Okay, 2 more. Let's say we're going over the x-axis and over the y-axis. Okay? I'm just going all the way on the right side, so I'm running into the next one. Okay, over the x and over the y. If you're going over the x-axis, it's negative on the outside of your x squared. If you're over the y-axis, it's negative on the inside of your x squared. Just like that. Okay, those are all the rules in a nutshell. Those are all the rules. Okay, so let's go back up to our function up here.
At the door, I'm pretty sure.
No, someone just shut
I think they just shut the back door.
Oh.
Okay, all right, so now we have these 3 things going on. This -4, go off of your rules, and how is that -4 moving it?
It's right 5.
It's going to the
I mean,
right,
4.
it's going to the right 4. Right, 4 units, okay? Then what does this 3 do?
It is.
It's way on the outside and you're multiplying it.
I don't know. There's no Z.
There's none like that.
There kind of is, but pretend that like your 4 is already gone now. Okay, so now that we've done the right 4, now we have 3x squared. What's the 3 doing?
Stretch.
Yeah, vertical stretch by 3. So after you've like done the transformation, you can get rid of it and just look at the rest of it, right? Vertical stretch by 3 is the 3 on the outside. Got it?
Yeah.
Yeah? Okay, I think you only have one of those.
Good. 'Cause I
Okay. Yeah, those ones are icky, icky, icky. Okay. All right. Determine whether the graph of the following relation is a function. Yes or no?
Yes.
Yes.
Yes. Why?
Because I don't know.
Because why? Why is that a
Vertical
function?
line test.
Vertical line test. Passes vertical line test. It passes the vertical line test. Perfect. Okay. Number 20. What does it mean when it says f of negative 2?
We plug it
Put
in.
negative 2 in for
Yeah,
x.
that's all you do. You plug negative 2 in. All right. So 3 times negative 2 to the third power minus 2 times negative 2 to the second power minus 6. If you want to try to plug it into your calculator, go for it, but make sure you're using parentheses correctly. Okay, 3 and negative 2 cubed is negative 8. Minus 2, negative 2 squared is 4. Minus 6. I'm going to do this in my head and you tell me if you get the same answer. So negative 24 minus 8 minus 6 is,
I don't even know.
I think that.
Let me check it out.
That's what I got.
That's what you got. Perfect. Okay.
Yep, I
Practice
got that.
practice typing it in so you know that you did your parentheses right and everything.
Miss
Okay.
Blanchard, do you have all your Christmas shopping done?
Pretty close, yeah.
I don't Christmas shop with people because the last time I did, I Christmas shopped for my mom and she just threw it away. So
That's not very nice.
no, she's not a very nice person.
All right, chapter 3 has to do with quadratic functions. This is all quadratic functions. Ugh. All right, number 3.
Very expensive one, and she just threw it away.
Determine whether the following function has a maximum or a minimum. Okay, max or min. And we don't have to find where the max or min is. We just have to state whether it has a max or a min, and then find the y-intercept. Okay. All right. So, first of all, what is this thing going to look like if I were to graph it? If I were to graph
It
it.
has a
Negative.
min because there's a negative. Right?
It
Not
has a maximum,
necessarily.
it's a negative.
Ow. It's
Jeez, I love it.
If I were to graph it, it's going to be a frowny face, right? So it's going to have a max or a min.
a max.
It'll have a max, actually. Okay. The y-intercept, again, you plug 0 in for x, but when I do that, what's the y-intercept going to be?
Negative.
-1. You guys know that's just that last number. Okay, so it has a maximum, and the y-intercept is -1. Perfect. Okay, good. Okay, find the vertex and the axis of symmetry for the equation from problem 26. And I think 27 we have to graph it. No, should not be problem 26. I have a typo. This should say problem 21, but I don't know. Somehow I moved my numbers around and I ended up getting a typo. So that should be problem 21. And then 23 should say problems 21 and 22 instead. Okay, so whatever. All right, so do you remember how to find the vertex? The vertex was this coordinate point. How do I find that coordinate point, or what's the little equation? Remember?
No.
What was that little teeny tiny equation? You use it to find this number and
Is
then
it
you
the
plug that
B?
in.
It's the B over 2A.
Yep, negative b over 2a. Negative b over 2a. And then you plug that in to find the other coordinate, okay? All right, so, negative b. What will negative b be?
-12.
-12 over 2 times a, and a is
3.
-3, okay? So that's -12 over -6.
So 2.
So 2 comma something, right? Okay, and I have to plug it in to find that something. I'm gonna move my AOS over. Okay, AOS.
So plug it in.
Okay, so we've got to plug it in there, all right?
For
I
x.
got to plug it in for x, yep. To figure out what the y coordinate is, I plug the x in, okay? All right, so it's over by that pink and blue water bottle. It's face upside down. Yep, do you see it? It's upside down.
11.
Is that right? Okay, there should be like 3 of them there, so just do that.
It's
All right.
11.
So -3 times 2 squared plus 12 times 2 minus 1
Equals 11.
equals 11.
Yeah.
Okay,
Yes.
this is 4, so -12 plus 22 minus 1. Yep, 11. So the vertex is at 2, 11. Okay. All right. Do you remember how to find the axis of symmetry?
No.
Okay,
Oh,
I'm gonna
wait.
go to the graph first.
I
thought we just found that.
We kind of did find it, actually. So that was the vertex. Oop, vertex over here. And we have to find the axis of symmetry. I'm going to graph the vertex, okay? The vertex is at 211, which is all the way up here. Yikes. We're off the graph. 2, 11. Sorry, I didn't give you a very good graph. 211, that's my vertex, okay? And then we also know that that's the highest point, right? The vertex is a maximum. We know that from here. And the y-intercept is -1. Okay, so he's crossing here at -1. Okay, do you see how that works?
Yeah.
Do you see what this parabola is going to look like?
No.
No. This is the highest point. This is the maximum.
Why did you get -1?
Okay, at -1 because that's what we said the y-intercept was. We said the y-intercept here was -1. So we're plug in -1 in on the y-axis, or the y-axis, and then my maximum is that 211, right? But that means that over here is also another point, right? Because he's going to look like this. Does that make sense?
Yeah.
That's what my parabola is going to look like. Okay, the axis of symmetry. Do you remember what that was?
No.
It's gonna have to be 2.
It's the line that it goes through there, right? Okay, and you said it's at 2, but we put, for axis of symmetry, we put x equals 2, right? Because it's going through the x-axis. If you just say 2, it looks like you're just saying a point, right?
So we can just use.
So x equals 2, and that will always, this number will always be the same number as this one, right? Does that make sense? X equals whatever that coordinate is, okay?
Okay.
And there's the graph. So 21, 22, 23 all went together. 23 is the final graph of it. So you're putting all that information together, okay? All right, so that means that if those are ones that are struggles for you, you better make sure you study them because that's 3 problems in one. And if you don't know how to do one, you might not know how to do the other 2. So you'll just be SOL, right? Okay, all right. The square root of 32, when they say simplify, they don't want a decimal, okay? So we want to break 32 down into some numbers, right? Okay, and numbers that I'm looking for are the perfect squares, okay? Perfect squares.
Not come out good.
Yeah, 32 does not come out good. Okay, perfect squares. Perfect squares are like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, or 25, or 36, or 49, or 64, or 81, or 100, right? That's up through 10 squared, right? I'm looking for those numbers, all right? Which one of those numbers goes into 32?
4.
Now 4 does, okay? But don't write this down, look at what I'm doing. 4 goes here, and 8 goes here. Technically 8 will break down more.
Yeah.
Is there a bigger number than 4 that will go into 32? 16, right?
Oh,
16
really?
goes in there, yeah, you're right. If 4 goes into a number, check and see if 16 does also, right? And you want to use the bigger number. So 16 and 2, okay? So that broke down into 16 and 2, all right? I take the square root of 16 and the square root of 2. What's the square root of 16? 4, and the square root of 2 doesn't break down, so it just stays as the square root of 2, okay? It stays on the inside. You remember how to do that?
Yeah.
Refreshing your brain?
To the...
Yep, I'll go to the list. Okay, so that's 4 squared to 2, that's simplified. These are your perfect squares if you want to write them down. That's up through 100. I mean, you could go higher than that, but I don't think you'll need to.
Okay.
So,
Alright.
4 square roots of 2 is what broken down should be.
I forgot how to do the subtraction.
Okay. All right, we ready for the next one? Subtract?
Yeah.
Okay, so when you're subtracting, all we have to do is just combine like terms, but subtraction, this minus sign needs to be distributed, right? So instead of that being 4, it should be minus 4. Instead of that being minus 3i, it should be plus 3i. Okay, and then that's 6 plus 2i, he's just going to chill, and I'm going to rewrite him so I can combine like terms. Okay, then we just combine. 6 and -4 can go together.
2 plus 5i.
And that makes 2. And 2i and 3i becomes 5i. You are right. 2 plus 5i. Those should be easy ones. Hopefully. Yeah, we're almost done. 2 plus 5i. Got it?
Yeah.
Okay, multiply. How do I multiply?
Distribute it.
You
Or
distribute
foil.
like foil, right?
Yeah.
So 6 times 3 is 18.
Minus 12i plus 15i.
And what's 5i times -2i?
Minus 10i squared.
Yeah, it's minus. 5 and negative 2
That
Minus
doesn't make any sense.
is negative 10.
There's a -2, you dinglebutt.
Yes, I understand that, but I thought it was like a bigger number.
No, because
None
we're
of this
multiplying.
makes any
We're
sense.
multiplying,
I
so you're doing positive 5 times negative 2. So it'd be negative 10 I squared.
And that's just positive 10.
And this, yep. So that I squared is negative 1, and so that just changes it to positive 10 instead. Okay, then we combine like terms. So 18 and positive 10 makes 28.
Plus 3i.
And then negative 12 and 15 makes plus 3i.
I don't know, I hate negatives.
Yeah.
I'm a guy.
Yeah, negatives are tricky. Okay, happy with that?
Yeah.
All right, 27, solve using I. Okay, we're solving for x, which means we're trying to get x by itself. Now, notice that that is not a trinomial, so we don't break it down. Yep, let's subtract the 50 over. I like that idea.
2x squared equals negative 50.
Negative 50. Okay, then what?
By 2.
Divide.
Don't, some people in, some people in the 8th period class like to take the square root. You have to divide by 2 first, right? Okay, x squared equals negative 25.
And then you take the square root.
And then you take the square root, okay? Now, we can't take the square root of a negative number,
X
right?
squared, or not,
So,
x
X equals,
5i and negative 5i.
yeah, because we put the square root in there, it needs to be plus and minus, and then this negative makes it an I, so plus and minus 5i. Questions about that?
No.
Yeah, that one's too bad, that one's pretty good. Okay, now we have 4 left, all right? And these are the fabulous 4.
Add the 8 over. You can add the 8
I don't think that's gonna work.
Why?
These are the fabulous 4.
How do you even do these?
These are the fabulous 4. These are the factoring methods.
I
Oh.
hate
Okay.
factoring. It makes me die.
I know. Factoring methods. Okay. All right. So give me one of the ways to factor.
You can add and then you can
Find numbers that add to get 7 multiplied to get 8.
Yep. This one is a simple trinomial. So I want to multiply to get 8, negative 8 actually, and add to get 7. Okay. So that's how you factor a simple trinomial.
1 and negative 8.
Okay.
2 and negative
So yeah, if you need to list out,
I don't think
we have 1 and 8 or 2 and 4. So which one of those combinations give you 7?
1 and 8.
1 and 8. Okay. If I want negative 7 though,
1 negative 8.
the 8 has to be negative and the 1 has to be positive. So it's x plus 1 and x minus 8, right? Okay, not done yet. I have to set them equal to 0, so x here will be equal to negative 1, and x here will be equal to positive 8. Perfect. Okay, all right, 3 left.
Now this one we just take the square.
What is 29? I didn't give you very much room. Somehow I got a typo in there.
Square what?
This one is a difference of squares, right? So I'm going to put a DOS next to it, okay? And we're doing the square root of x squared and the square root of 16, okay? So I have 2 bubbles. I'm going to do this one over here. I have 2 bubbles, 1, 2. What's the square root of x squared?
X.
Just x. What's the square root of 16?
4
4, and one of them is
negative.
plus, and one of them is minus, okay? So that's how it breaks down into x plus 4, x minus 4, yeah? Now, if I set them equal to 0, x equals the opposite sign, right? We flip them over. So x equals negative 4 and x equals positive 4. Yeah? Those difference of squares, those are really fast. Okay,
This
that was 29.
greatest common factor.
30 is a greatest common factor, exactly. Okay,
I don't know what that
all right, greatest common factor means you're factoring something out. You're factoring the greatest piece out, okay? So out of those 2 chunks, what can you take out of both of them?
means. 4x.
A 4 and an x, yep, so we do that. All right, and left over will be
X.
x and
Yeah.
minus 5, x minus 5, okay? Now what do I do?
I don't know. Oh, there's church
Just like what I've been doing before, I set each piece equal to 0. So here x equals 5, we know that, right? But if I set 4x equal to 0, and I divide by 4, x is gonna be 0, okay? So I'm still just, after I get them factored down, I just still set them equal to 0, right? Good? All right, last one. What's this one?
Complex. So 3 times 5.
Complex trinomial. All right. So do you want me to list out the rules or the
They just get confusing.
no?
Yes, list them out.
Yes, list them out. Okay, so you don't have to write them down if you don't want them. Number 1 is A times C. You know what I'm talking about when I say A times C? So 3 times 5 is 15. I'm gonna move that over.
Are you trying to find the factors of 15?
Yes. Okay, so 3
1,
times 5 is 15, and I have to find the factors of 15.
3 and 5.
So 1 and 15, 3 and 5, and I think that's it.
Yeah.
Okay? All right. So step 2, find factors. And I'm going to say find factors for B. What is B?
The middle number.
B is the middle number, right?
It's
Negative 16.
It's negative 15 plus 1.
Yep. So negative 15 and negative 1. No, it should be both negative, right? Negative 15, negative 1. Did you say that?
No. I said positive 1. No.
Because you want them to add to be negative 16,
Yeah, I got it.
right? Okay, find factors for B. Okay, then step number 3. After we find those factors, which you said were this,
So
right?
it's going to be 3x squared.
Right,
and
4
in
pieces.
parentheses, It's going to be x minus 1, and then it's going to be x minus.
Now, hold on. Whoa, just a second.
You gotta like put
Nope, you don't quite write. Yeah, we have to write out our 4 pieces first. So 3x squared stays, and plus 5 stays. But this guy breaks down into 2 pieces. So minus 1x plus or minus 15x.
Oh, I put it in parentheses.
Yep, not yet. Not until you group. So you have to write out your 4 pieces and then you group.
That's what I
Okay, so factor by grouping.
Oh, it's not minus 5x.
Okay, so you have to write out your 4 pieces first, then you factor by grouping. Okay, if you want that 4th step there. All right, so I grouped the first 2 chunks and I grouped the second 2 chunks. What can come out of the first chunk?
1x.
Just x, right? 1x, okay? And left would be 3x minus 1. Okay, what do you want to come out of the second piece?
5. And then that's going to be negative 3x.
You got it, but you got to take out a negative 5 in order for it to be 3x minus 1 again,
No.
right? So let's take a negative 5 out so that it matches,
How can you take a negative 5 if you don't have a negative 5?
because that'll just turn this positive 5 into negative 1, right? Which is what I want it to be, right? I want it to be 3x minus 1. Otherwise, your bubbles, your 2 things in parentheses won't match. They'll be opposite sign. Does that make sense? I'm going to pull a negative 5 out. Okay? All right, then we're almost done. These 2 pieces, what are my 2 pieces?
I don't know.
X minus 5.
X minus 5,
3x
right?
minus
This guy and 3x minus 1. Okay? X minus 5, 3x minus 1. Do you see how we get those numbers?
Yep.
Okay? Now, if I set them equal to 0, x here equals
5.
5, okay? Now, if I set this one equal to 0, you might not be able to do that in your head, or some of you might be able to. That's exciting.
It should just
Let's
be-
add the 1 over, okay? So 3x equals 1, and then divide by 3.
It's 3. I mean 1/3.
Is 1/3. Yep, x equals 1/3. So those are my 2 answers. Now, these last 4 problems, these are the fabulous 4. What were we even finding when we were doing these? What are the 2 answers find on each one?
X and Y. I mean X and X.
X and x, but what do those find? The what? No.
No.
What are those things finding?
No, I don't.
What do each one of these look like?
the
X
intercepts.
squared. Yeah, those are the zeros, the x-intercepts, right? Each one of these is a parabola, right? So I'm finding the places where he crosses, right? Each place. So each one of those has 2 places where he crosses, right? Yeah, happy with that? There you go. Okay. All right. Does that sound good? Do you guys wanna? Let's do this. Here's what I'm gonna have you guys do. I gave you guys a separate sheet of paper, and here's what the separate sheet of paper is. Aubrey was out of the room when I said this. So your separate sheet of paper that you have has a thing that looks like this, okay? This you can't use on your test because it's gonna be almost the same. I'll answer it later. It's almost gonna be exactly the same on your test, so I don't wanna let you use the whole answer sheet thing. So why don't you go ahead and try to match these? So figure out for linear all the way through which one their equation matches and then which one the graph matches. You guys had to do this on a test once, I think,
Yeah,
right?
I don't
So let's do
remember.
linear together. Which one of these functions right here is a linear function?
I said R.
R, you said R. What? Oh, R. The graph R, okay? So I'm gonna put R right here, okay? which equation is linear?
How do we find
Is
that
it
out?
Is it E?
How do we find that out? I don't know.
Like which one is a linear function? Which one is a linear graph?
Should be
Lines, linear functions look like mx plus b.
It's
Yeah.
E.
E, right? 3/4 is your m and -6 is your b. Yep, that's E.
Why did we
Good.
know that?
Yep, and then go through quadratic. Quadratic is x squared, right? So figure out which one of these functions is x squared. Now, I understand that a has an x squared in it, right? But that's not a quadratic function because that's not the highest power, right? Okay, so quadratic. Figure out which one is quadratic, okay?
It's
I.
I, you think?
Yeah.
Oh, yeah, it is. So I, and which graph is quadratic? Which one? What does a quadratic function look like?
L.
Yeah, it looks like a parabola, right? Quadratic function is L, okay? All right, go through those and try and see if you can match them, and then maybe we'll go through the answers tomorrow or at the end of the period if you want to just check them, okay? Good? All right,
Wait,
here we go.
is cubic M?
Cubic is
Yeah.
M, yes. All right, goodbye people watching this.